Here we go again. We got a Leslie here, Chief Meteorologist Dan Scoff, and the Weather Lab meteorologist Leslie and Leslie Castro. You ready to have another potential sighting
I'm
tonight?
excited. Hopefully there is a successful round two
Yes.
here.
So always a question, and it's always a forecast. However, I will say this, that the impact has been felt already
Yes.
by the instrumentation. So there was questions as to whether that third CME shock would in fact impact the U.S. and as well as basically the entire North Pole of the Earth. There was uncertainty as to whether that third CME was actually combined with the one last night.
Yes.
Not the case. We actually have a contact to what we call DSCOVR, which stands for Deep Space Climate Observatory. So that's where you get the acronym DSCOVR. Let's take a look here at some of the latest data. And of course, while we're doing that, I'm going to continue with this gorgeous here. We're going to go back to that gorgeous time lapse because that time lapse was pretty awesome. And you'll see right here, that's when the colors are really popping last night. But what we're going to do is we're going to share the screen. I want to show you the real-time solar wind information as I pop that up on the screen as we got the time lapse. So you'll notice as we look at this, this is what we call DSCOVR, and here is the impact of the CME. Now, it's just started, and it started a little bit earlier than yesterday. So, but you'll see here how the impact has definitely made its impact on DSCOVR. Notice one of the things I'm really seeing is the increase in the solar wind speed. So we know that this is definitely an impact from a coronal mass ejection, which is that plasma cloud. I'm going to zoom in on this a little bit more and watch this rapid increase in speed. Also, rapid increase in density. And now we got the fluctuation of the Earth's planetary magnetic field. And you can see how that is going up and down. And so that's exactly what it did yesterday, Leslie.
Mm-hmm.
And it just all depends. Here's the thing. It doesn't matter how impressive this is in terms of its impact. It's all how it interacts with the Earth's planetary field. So here's what we essentially have to say. If you have a magnet, we'll put this a little bit smaller so we can see you. So if we have a magnet and you have negative ends repelling, right? Positive, positive, negative, negative, what happens? Then the magnets spread apart. They basically repel, which is what's called repelling. However, if you have those magnets that are negative and positive, then they attract. Well, if this southward pointing magnet field from the plasma cloud is predominantly south pointing, then that's going to connect with the Earth's magnetic field, and that's going to create that charge. Last night was awesome and spectacular, no doubt. In fact, here's another. This is a 4 times time lapse. Look at that, and you'll see some greens dancing around as well. But we know that that third impact has arrived. It arrived approximately 1:15 local time, 19:15 UTZ. You can see as we're looking at this is spaceweather.com, just an amazing site. We'll take a look here at this tab. So the third CME has arrived. It is that highly anticipated third coronal mass ejection. That's what CME stands for. Think of a plasma cloud full of charged protons, ions, neutrons, all that stuff that's headed towards the Earth. And it struck the Earth's magnetic field at 1915. So if we go back to this, you can see right here, 1915 is the time that impact was felt, maybe a little bit before 1915. It looks like maybe 1852. So approximately, now it hit one of the outer satellites, but you can see right here with DSCOVR, that's showing that increase. And something right here happened, obviously, because it's totally streamlined and then flatlined, and then all of a sudden started to increase. But we'll see what happens as if it continues to drop negative or not. We'll continue to update it. This is what happened last time, and we're going to look at the timing of when this impact took place. Now, you notice it's a little bit later, 23:36. That's known as 5:36 local standard time, since we're not daylight time anymore. You subtract 6 from UTZ. So when it's 11:36, you subtract that 6 and you get 5:36, which is basically a little before the 6 o'clock news. We know that it took about 2 hours for that to really start to evolve and then drop way down to negative 55. Now, negative 55 is no doubt a pretty impressive, you know, negative BZ. The planetary field was extremely negative, and that is where you had that interaction of the excited oxygen and nitrogen molecules at different levels of the atmosphere causing the aurora. And notice how it stayed negative for a while. Sometimes it bounces up, and then your show kind of, you know, let's just say flickers several times, or comes in waves, which is exactly what this did. If you go into the later hours of the night, there was a time when the solar storm subsided, then it came back, then it bounced back up, and it came back again, and it bounced up, came back again. In fact, in the early morning hours, there was still a little bit of that, you know, that CME. I'm going to refresh this. We'll take a look here at the entire time of the solar storm. And so here's the early morning hours. You know, here's 5 o'clock in the morning, still negative, not quite as negative as it was here. But if you are wanting to know where, you know, if the northern lights are going to happen tonight, because I know a lot of you are wondering about this, this is the best site, in my opinion, spaceweather.com, or you can go to spaceweatherlive.com. There's many different sites, but I like this because you just go right here, discover, click on that. And if you see this BZ going very negative, the red line is the NT. It's basically the total electric field, and then you can see that going down right there, but then kind of bouncing back up. So reverberating. We don't know, but one thing I think that is pretty exciting, Aleshli, is that speed is increasing quite a bit. When the speed increases, that's the solar wind speed. So we know that there's more to the CME that's coming in.
Okay.
So yeah, some exciting stuff. So we know that the third impact has been felt. We don't know exactly how it's going to interact with the Earth's planetary field. I don't know why sometimes it does that. So we'll go back here. We'll try this one more time. And yeah, sometimes it does that. It acts kind of finicky and acts kind of tricky. But anyways, so that's what we're going to be looking for. Right now, the Earth's planetary field is quite a bit north, if we refresh that. But it's going to bounce around. Now, when it goes way up, what goes way up must come way down. Now, Leslie, you are kind of learning space weather. I'm learning it as well. We tried to get a space weather scientist on, but they are too busy to do this, unfortunately. But here's my question. Do you have any questions about the northern lights that you think people out there might want to know?
I think I asked you the question yesterday, but I'll bring it back up just for the audience as well.
Yes.
And like I told you, like we had the first, CMEs come in yesterday. And I said, would that weaken the magnetic field for this third CME to come impact Earth a little stronger, if you will?
I think that we had the Earth's magnetic field, and I'm not an expert on this, but looking at how long it stabilized, there was enough time for it to stabilize and to kind of to come back. It wasn't like, if you think about it, I was kind of explaining it like this, like blowing out a candle, if you will. If you just got a steady breath on it, not very strong, the candle will flicker, try to go out, but then as soon as you stop blowing, the candle flame will start coming back straight up. That's kind of what I think what happened, because if we come back to this, we'll take a look at this and we'll bring this back up on space weather. This is Discover, where you can see that. And I hope I can zoom in now. Let's see if it does it. Okay, there we go. So if you zoom in too much, it messes up. This right here was a time when I think that magnetic field was able to able to stabilize again. That's a long time.
Yeah.
So I'm not exactly sure how much of an impact the previous one had on that magnetic field, or how much it's impacted, but it does look to me like it's pretty stable there. And that's about where it is. If we look at a 7-day timeline and go back, and you can look at this, this is pretty stable right here. And so stable, 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 and then bam, obviously that's when that hit. And you can see the one last night.
Yeah.
That was a very impressive solar storm. We were looking at it, I was like, oh my gosh, it got down to negative 50. negative 50 is way, way down there. So we knew something was going. So yeah, I still think that you just never know how this Earth's magnetic field is going to behave, like in terms of, how strong is essentially the southward pointing magnet field going to be. We don't know
Mhm.
that. There is no way to tell. So if it's more positively pointed magnetic field, then we won't get much of an interaction at all from
Okay.
the Earth's magnetosphere. So if you get to a KP8 like we did yesterday, a KP8 or a 9, then we have that potential. Let's take a look at Space Weather Live. They have some stuff on the auroral, and so does, of course, Space Weather Prediction Center and all that stuff. And we'll see what their latest update is too. Right now, our KP index is not a factor because we're way down. In fact, we're positive right now. But we'll take a look at the auroral activity, look at the aurora forecast, and we could come down here and now see this is too late already
Yeah.
because it shows that we should be from 15 to 18 Z, which is basically 1 o'clock this or 2 o'clock this afternoon. We should already be at an 8. I know you're not seeing this. Let me show you what we're looking at. So we are still expecting a potential KP index of 8. Has to get a little over an 8 to see a very impressive, solar storm like we saw yesterday. By the way, there was signs that it might have gotten to a KP9, which is a G5.
Oh, okay.
That's what Dr. Tamitha Scobb said. This is definitely a difficult forecast, but if you'll notice here, we scroll down here, this is the forecast showing a KP index of 8. That's the predicted KP index. But keep in mind, this is already we're already at 2 o'clock. And if we go to what we're actually at, it's nowhere near. The KP is 5 right now. So that's
Mhm.
underdone. Now that's good and bad. It's good because maybe it's a little delayed. And if it's
Yeah.
delayed, of course, then that means, Leslie, that we'll have time for that Earth's magnetic field to go negative more,
Okay.
which will cause more of the northern lights. Speaking of the northern lights, this is again the show from last night. My goodness, that is just awesome. It really was. What was it like when you were out there seeing it,
It
Leslie?
was, I mean, obviously with the naked eye, I was able to see some of it, especially since the city lights were right below. But I think it was still very impressive. You were able to tell, the pink hues, you would say, and a little bit of the green. But, as we've spoken about before and plenty of times, once you use your phone with your night vision
Yeah, yeah.
and with longer exposure, it really comes out beautifully. So nonetheless, being able to see that out here was honestly really incredible. And I've seen it a few times back home in Ohio, but the fact that I was also able to see it here,
Here, I
I
know.
was like, wow, this is impressive.
And for the naked eye viewing too. That's
Yeah.
what, even though, I mean, and there were times when naked eye was really visible.
Yeah.
So
And so
look at the greens right
and
there showing
Davion
up.
was with me too, and we were looking out the window. We are like, "Oh my gosh, there it is, there it is!" And we were
Yeah.
just trying to get there on time to be able to capture some of it. But nonetheless, it was very beautiful.
But you can see how it comes in
Oh yeah,
waves. So it's almost like a gust front, if you will, of a storm.
yeah,
They'll those nitrogen and oxygen molecules will get excited
yeah,
and they'll come in waves.
yeah.
Look at how that green shows up, and then it kind of dissipates. So as Wayne just said, use your phone camera and you can see it real good. Even
Hmm.
without taking the photo, you can just hold your phone camera up and it has a little bit better of an iris. Your eye is a great iris too, but the
Yeah,
problem is light pollution will affect that big time.
definitely.
And it's called like a low
Yeah.
lux. These cameras work pretty well at night. So excited because you saw some of the other cameras; they
A
barely
lot of
showed
yeah.
the aurora. But I am interested to see what happens and see if we actually do have as spectacular of a performance as last night. I have questions about it. I do, but we know that another CME has impacted the Earth. This is, by the way, I'm gonna share this again, and so you can see. We're gonna bring this up full. But here's a look at that CME impact. I'm gonna make this full screen so you can
Mhm.
see. Um, but right here is your impact, I do believe. Maybe not. Maybe not there. Maybe this is like a precursor. I don't know what
Mm.
this is, but something hit there. but I think like right there is the actual impact. So what they were saying, 1915, that looks about right. And then you can see right here it goes down negative, but look, this is really positive. Now, will it bounce back? Who knows? That's where the big
Yeah.
question is.
I
If this
mean,
bounces to negative, then we're
because
golden.
yesterday it happened so
It happened
rapidly, but
fast.
this time around you can tell it's taking its time.
Yeah. But it's okay.
Yeah,
Sometimes
yeah,
it
yeah.
does. Sometimes it does take its time. The initial particles that, the proton, essentially the plasma cloud, as it hits the Earth,
Mhm.
initially it might be northward pointing magnet field and then it switches to south. And you saw how it did that in that time lapse where it kind of flickered.
Yeah,
That's exactly what was happening.
like a little reverberation,
Yeah.
if you will.
One thing I do like though is the speed. The speed and the density. Look at
So
how all
consistent,
both of
yep.
that has increased. So
Mhm.
but it all depends on the magnetic field. So we've answered a few of the unknowns. We've answered the question about the timing. We know the timing right now. So we don't know the timing as when that's going to flip. And another one is we don't know what the magnetic field is going to be, what direction it's going to be pointing.
Yeah.
So those are kind of the three things. We knew an X 5.1 was an impressive solar flares, no doubt about that. We knew it was a full halo CME. So, like we said, that coronal mass ejection, the plasma cloud, is headed towards the Earth.
Yes.
If you see it releasing from the entire sun, because it makes
Mhm.
sense. That means it's coming right towards you and coming towards the Earth's sensors too. Soho saw that. LASCO, which had the essentially the grainy image, that showed the amount of radiation that was
Mhm.
being released, and that really impacted the sensors. So that's we'll go ahead and run this a few more minutes, but stay tuned because we know that it hit. We don't know that negative field, but again, if you're just joining and you're like, how do I know if the northern lights are going to be possible tonight? It's not set in stone. It's not for certain. But if we go to here and you go to the aurora and you look right here, we got to get this negative. That BZ, that is the key. Everything else, you can have the speed, you can have a solar wind, yeah, you can have some northern lights impacts, but not necessarily it's got to go negative. And if you look, to me personally, I'm going to show you the time scale. This is what happened yesterday. That really did a lot. But also notice the speed is faster on this one. So down here, this
Mm.
purple, that's the speed kilometers per second. And we're talking 730. This is like at one point it measured almost 1,000. If you really zoom in on that, 894. It's so far zoomed out that you can't get to it, but it bumped up to almost 1,000. You can see the scale right
Yeah.
there. That's pretty
Interesting.
fast. And there's also like this big lull too. So, it kind of reminds me of like a tsunami. When a tsunami comes, what happens with the water at the shore initially? It'll
It'll
retreat,
yeah.
right?
Mhm.
It basically
Kinda
recedes.
recedes, and
Yeah.
then that's when you're like, "Oh, no, I should probably
So
go
that
somewhere high." Yep.
receding
Mhm.
of the shore of the water pulling away and then it
Yeah.
comes back in. What if this is actually like a receding of the
That's
energy
a good
coming
way
in?
to put it
Yeah,
when you compare it in that manner, and it's also like with tsunamis as well, you can't necessarily predict how fast it's gonna come back as well
exactly.
sometimes.
The other with the multiple waves. So there's
Mhm.
multiple waves. So think of this like a tsunami from the sun of a plasma cloud.
Yeah.
I think that's a great way
That's a
to put
great
it.
way to put it, yeah.
And then you can see how this drops down like pretty big time. So let me zoom in on this area right here. I don't know why it does that. I guess when you zoom in too much, it just cuts it out. But now we can go to the speed, and then you can see right there, it's like 809. Let me see if I can zoom in any more. It looks like it peaks way up there.
It does look like it. I can't go in any closer than
Yeah, if I
that.
if I go in any closer, that could just be an error too.
Okay.
But anyways, still very fast, still very positive. That's not real great. But if we look at some of the conditions, they're still expecting a G4.
G4.
We're already at a G1, and They're even showing potential for G4 tomorrow. So this sometimes can be a delayed effect. It really can. I've seen it where it's like 12 hours later, and then all of a sudden it
Yeah.
just flips to negative. So that's what we're going to be watching. That's what we're going to be checking out. So again, the uncertainties, as we mentioned, is that going back to this, we're going to go to this time lapse and show a little bit more of the northern lights from last night. So the uncertainties are we don't know if that magnetic field is going to be negative. It has to be in order for the Earth's magnetosphere to attract the protons, exciting them, charging them up, getting them to different colors, different levels. In case you're wondering, too, we've got a few people on here. I'm going to go to our aurora forecast. Not the aurora forecast, but I want to show you, and I've updated this, the colors of the auroras, if we do in fact see the northern lights. So here's a graphic that will kind of explain what we could experience tonight. So there's the Earth's magnetic field. Then you've got these charged plasma clouds, like think of them as plasma tsunamis that get released, and they're spreading out towards the Earth. And then those magnetic field bands get bent and snapped, and then when they snap, that's what excites the charged particles. So the electrons collide with various molecules in the atmosphere, and then the resulting excitation of those basically collisions is what causes the different colors of auroras. Now, the red auroras, and this is what's interesting too, is you'll go through a lot of stuff. Let me show you this graphic here. So we'll go back and we'll show you this. So magnetic field, there's the aurora borealis. By the way, aurora australis is the southern hemisphere. It's called the southern lights. So it happens just the same in the South Pole. And then sometimes those where the Earth's atmosphere, the magnetic field is weakest, that's where at the poles, that's where that magnetic field can be attracted. So those electrons collide with various molecules in the atmosphere, and the resulting collisions cause the different colors. Now, you can look up heights of these auroras, and you're going to get all sorts of different answers. AI, NASA, and depending on this, but when we come to the conclusion is that the red auroras are the highest, which is why they're the easiest to see. The green auroras are 80 to 250 miles up, which are oxygen molecules, even though NASA says nitrogen in their thing, and it's not. Then you got nitrogen and oxygen molecules for blue auroras, but purple auroras, you got mainly nitrogen, and then up to 60 miles for blue auroras. And most of that is nitrogen, but there could be some oxygen. And blue auroras are very rare to see because you got to be very close to basically the northern lights in order to see them. If we get blue, that would be pretty impressive. So there's an example of what we could see. And someone's saying, I just remember these big solar flares are exactly how the movie 2012 started. Not only that, but if you've ever seen Knowing with Nicolas Cage, it's ridiculous.
I'm not good with movies, so if you
pull
a trivia on me when it comes to that stuff,
it's ridiculous. How about this comment that I look like Tom Brady? I'll take that. I will take that comment. Tom Brady is well, my wife says he's a good-looking guy, so let's just I'll take that. I'll take that.
Okay.
And that's awesome. That's a good comment. All right. Well, we're going to shut it down here. 30 minutes. Just remember that BZ. Let's see what we're doing right now. And it's still quite a ways positive. I don't know. It doesn't look super impressive at this point. Let me show you. Last view. This is what it's all about. Everything else is now casting now at this point. That does not look very impressive. Speed does.
Again, it's just a matter
does.
of we'll have to wait and see what happens next.
Wait and see. I'll tell you what, we'll keep you updated. I'll have the latest on the newscast tonight. We'll tell everyone what's going on, and just prepare for the potential to see the northern lights. But I think last night was the show.
Yeah.
As of now, but we'll see. We'll see what happens. All right, take care, guys. Thanks for watching. God bless. We'll see you guys later. I'll have another update tonight if things start cooking a little more. We'll see you.